Hello guys, what's up? It's me, Engineer AK, and today we are going to start the second lecture of the first chapter. That was metal structure and crystallization. So today we will discuss some more basics. So our first topic is atomic arrangement, right? So in atomic arrangement we have some subtopics. The first one is electronic arrangement. What it is, electronic arrangement is the arrangement of electron in shells, right? Like how the electrons are arranged in their shells. And we know from our high schools concepts that maximum number of electrons that in a shell is 2n square, where n is the number of shells, right? The second term is atomic number, that is represented by Z, and it is the number of electron or proton in electrically neutral atom, right? That the atom should be electrically neutral, so in that atom the number of proton or the number of electron is known as the atomic number. For example, if I take example of oxygen, so it have atomic number 8, right? Mean it possesses 8 electrons and 8 protons, right? The second term is atomic weight or atom weight, that is represented by A and also by U, and it is the neutron plus proton or the neutron plus electron in electrically neutral atom, right? For I'm taking the same example of oxygen, so we have atomic weight or atomic mass 16, and here we can see that's oxygen, and that is its atomic weight or atomic mass, and that is its atomic number, right? Moving further, we have now Pauli exclusion principle. So this principle was first proposed by a Austrian physicist Wolfgang Pauli in 1925, and this principle states that no two electrons in an atom having the exact same quantum number, right? Or we can say that no more than 2 electrons can fit on any one energy level of same spin. Mean if there is an energy level, right, and it has 2 electrons, let's suppose, so this energy level, in this energy level the electron must possess opposite spin, right? We cannot place 2 electrons having the same spin in the same energy level, right? Okay, the inner shell will be filled first. Okay, first the inner shell will be filled, and then in the second and third and so on. But in some cases, in heavier element, the scenario may be changed, so it's not true for the heavier element, right? Okay, it helps to determine the number of electrons that occupy each energy level and orbital in an atom. Okay, it also tells us the number of electrons, that how many electron an energy level possess, and or in orbit how many electrons are there, right? And it also give the concepts of the nature of the matter and behavior of the particle at a quantum level. Mean we can discuss, or we can study the behavior of the particle at very low energy, at very low level, right? So let's see this diagram. So in this we can see that the first one isn't correct, because as we according to Pauli exclusion principle, no two electron will having the same spin, right? Same with the case the third one. Here we can see that they are having the same spin. But if we see this one, so according to Pauli exclusion principle, it is the right one, because if we can see that the both electron possess opposite spin, or we can say that they do not have the same quantum number, right? Exact same quantum number. Okay, So moving further, so the next topic is modify Neil Bohr's model. So it's actually the wave mechanical model, right? So the previous model, like in Bohr model, as we discussed before, that according to a Bohr model, the electrons revolve around the nucleus in a circular or elliptical orbits, right? We have already discussed it in a previous video. So in 1920s, Heisenberg and Schrödinger work on the Bohr model. Mean they work on the already existed model of the Bohrs and made some changes into it or modify it, or do they do some modification in Bohr's model. Okay, and what they do, that they said that electron do not possess only like it do not have the behavior of particle, but as well as it has the nature of wave. Like electrons are not thought as particle moving in a fixed orbit around the nucleus as in earlier Bohr model of an atom. Like according to a Bohr model, as I told you, that according to Bohr model, the electrons revolve around the nucleus in a fixed orbit, right? That's what the Neil Bohr model says. But uh, after the Heisenberg and Schrödinger, they say that electrons are described as a wave that exists in a certain region of space around the nucleus. Like they said that there are clouds of electron around there are clouds of electron around the nucleus, and there are also some orbits around the nucleus in which the electron exists. Mean there are cloud of orbits around the nucleus in which the electron will exist, right? So through their work, they still didn't find the exact orbit of electron, but it gives the probability, right? Like for example, if I say this is a in this diagram, I can, like, probabilities mean there are chances that it might be possible that the particle will exist here. Like the orbital that exists here, in that orbital might be possible there's the electron or the particle we are searching for, right? And the probability is found through a wave functions, right? And when we solve this wave function, so we get four quantities that are known as quantum numbers that we will discuss later. So this was the first Neil Bohr model, right? Neil Bohr model in which the electrons are revolving in a circular or elliptical orbits around the nucleus. And this is now the quantum mechanical model, right? In this we can see the electron clouds orbital. There are clouds of orbital around the nucleus in which we find the probability of a particle, that where it exists or in which orbital that particle exists, right? So what are the quantum numbers? The quantum number are the set of four numbers, right? We have four quantum numbers, and what this quantum number do, that it determine the arrangement of electron in orbital and energy level of an atom, right? It tells us that how the electrons are arranged in orbitals and in the energy level of the atom, right? Through this we determine the chemical and physical. So if we know the arrangement of electron in orbital, so through this we can then find that what chemical and physical properties an atom have, right? Or what physical and chemical properties an atom possess, right? Describe the complete electronic structure of an atom and properties of electrons. As I told you, that this give complete electronic structure, right? And the properties of electron as well, right? Like in which orbital it exists, right? In which energy level it exists, and all those stuff. We can understand the particle at the atomic and subatomic level. Mean it in a nutshell, the quantum number give the complete picture of the atom, both at macro and micro level, meaning at atomic or subatomic level, right? So the first quantum number is principal quantum number, that is represented by the n. It describes the energy level of electron in an atom. Determine the size and shape of orbital in which the electron is formed, right? So in this we found that energy level of electron, for example, this is n1 mean this is the first shell, and 2 mean that's the second one, and 3 it mean the third one, right? Okay. And yeah, these are not too much important regarding the exam point of view, but you must you should have a concept, right, about these basic terms that will be helpful in your further chapter. Okay, azimuthal quantum number, it is represented by this small l. It describes the shape of orbital in which electrons form, right? It tells us the orbital shape, that what is the shape of the orbit in which the electrons exist. Determine the subshell of electron. Okay, for example, if I say I is equal to 0, L is equal to 0, so it corresponds to S subshell. If I say L is equal to 1, so it's P subshell. L is equal to 2, D subshell, and so on. And this, through this we can see that 0 for S, 1 for P, 2 for D, 3 for F. And if it's S subshell, so it will be having sphere shape. If it's P, so dumbbell shape. If it's D, so double dumbbell or complex. And if it's F, so we get a complex geometry. Sorry. Number third is magnetic quantum number, that is represented by the m. So it describes the orientation of orbital in space, right? It tells us the orientation of orbital, that how the orbital is arranged in a space, right? Determine the specific orbital in which the electron is found. For example, the p subshell has 3 orbital, right? -1, 0, 1. Like for example, for p we have 1, as we have discussed here. For p we have 1, so you can take from 1 to -1, from +1 to -1. If it has 2, so you can take it, so it will be having subshell from +2 to -2, mean +1, +2, +1, 0, -1, -2, and so on, right? And now from this picture we can see that its orientation is z-axis and x-axis and in y-axis, right? The last but not the least, spin quantum number. Determine the direction of electron spin, right? It tells us the electron spin direction, right? It can have a value of plus 1/2 or -1/2. For example, if we see in this picture, so the one is rotating in a counterclockwise and the another one is rotating in a clockwise. The clockwise they have represented by -1/2 and counterclockwise by +1/2. You can change the sign, but they should be having the opposite signs, right? Okay, so this is the last topic of today's lecture, periodic table. You all guys know what is periodic table, but there are some new terminologies or new terms that you people should know, right? So in periodic table we have groups. What are groups? That same property element are arranged in a similar column or group. The element that possess same properties are arranged in a column or in a group, right? And what is period? Element arranged in an increased atomic number. You all people should know that if you have studied the trends in your high school, so that say that if you move from left to right in a period, so their atomic weight increases, right? And that what we call it period. Now metal, you all know that it is a good conductor of heat and electricity. Non-metal do not have the properties of metal, mean it is opposite to the metal, mean it do not conduct heat or electricity. What are heavy metal? That have high atomic weight and density, and the light metal is opposite to the heavy metal. It has low atomic weight and density. Now what are metalloids or semi-metals? So from name you will understand that it is semi-metal, mean it hold both the metal and non-metal property means some properties of the metal and some properties of the non-metal, right? Now from and brittle and ductile. Now from mechanics of material course, you better know that what these terms are. So brittle, breaking under stress without significant plastic deformation, mean it do not give any warning and it plastically deform, or you can say that it hold very low energy, and they become fail. What are ductile? Have ability to stretch and deform without breaking or give good deformation, right? So it hold quite good energy till rupture point, right? Now inert gases, chemically inert and do not react with other element, right? So this periodic table is I have taken this from the book. So here these are the elements in a blue rectangular shape. These are the light metals. These the green one, these are the brittle, right? Scandium, titanium, and vanadium, chromium, manganese, so on. These metal in a yellow box, they are ductile, right? Iron, cobalt, nickel, and so on. These elements that are in the blue box are elements that are having low melting points. These in the red one, in the red blocks, these are metalloids, right? And these are inert gases. And if we at broader level, these element, as you can see, these are heavy metals, and these are the non-metals, right? And these are the light metals, right? So thank you so much. See you in next video. Take care.